Welcome back to Learning with me, Ms. Killen, here at MPB. We are in our 9th unit. We're looking at functions, a review for linear, quadratic, and exponential. So let's go ahead and look at lesson 2. We're contrasting three functions. I can compare and contrast the three functions through their characteristics. We're looking at f, IF4, and FLE1, A, B, and C. So let's just go ahead and dive on in. Now, there's some things that we've got to remember. We've got to remember the formula for linear equations, y equals mx plus b. We've got to remember the quadratic equation, ax squared plus bx plus c, and our exponential equation, which is y equals a times b to the x. We've also got to remember that we're looking for our slope, common ratio, those x and y intercepts, and we've got to also keep an eye out for those range and domains. So let's analyze the following graphs. Determine if they are linear, quadratic, and exponential. Find the difference. Keep this question in mind. How can I distinguish all three functions apart? So let's go ahead and start with this first one, my x and my y values. Now, how am I changing from here to here? I'm adding 6. Okay, since 13 is not anything that I can multiply 7 and get, so I know that. So what do I do to go from here to here? I'm adding 6. Same thing here. I'm adding 6. Same thing here. I'm adding 6. So I am changing from one point to the next constantly by adding a 6. So what type of equation or function do we say that is? It's linear. So let's go ahead and put linear down. All right, so let's look at the next one. Let me grab another color. We all know Ms. Killen's about the colors, so let's get purple. So I have from this point to this point. So I'm adding 6, I see, but then from here to here, what am I doing? I'm adding 18. And then from here to here, what am I doing? I'm adding 30, and then from here to here, what am I doing? I'm adding 42. Well, Ms. Killen, that's no way, shape, form, or fashion something of constant change. It's not. But let's go a little deeper. Let's look at maybe another variation of change. So what do I do to go from a change to 6 to 18? I can multiply by 3. So let's see if that'll work. I multiply by 3, and I get that change of 18. Now, what can I do to multiply by 3 to 18 to get 30? No, I can't. So I can't say that it is a change of adding 3, but let's go back and add. What would I change by adding from my 6 to my 18? I could add 12, yes. So sometimes we have to look at these different variations. So then, could I add that same 12 to 18 and get 30? Yes. So I'm adding 12 again. So what about from that 30 to 42? Am I adding 12? Absolutely. So I have a constant way that I am changing. Not a constant rate of change, but a constant way I'm changing. So what did we say in our past lessons when I have a constant way that I'm changing? It's quadratic. Good job. So let's write quadratic. I'm just going to put quad for short. Now let's look at our last one. Let me grab one more color. Let's do green. Now what do I do to go from here to here? Obviously I could add, but is there anything else that I could do? Well, I know that 6 times 7 is 42, so let's see about multiplying by 7. Well, what would I do to go from 42 to 294? Could I possibly multiply 7? Try it on your calculator and see what you get. Exactly right. So go from here to here, I am multiplying by 7 again. Try it one more time. Take 294 and multiply it by 7 and see what you get. You get 2,058, so I'm again multiplying by 7. One more time in your calculator, put 2,058 multiplied by 7, and what do you get? Exactly right. You get 14,406. So I am multiplying by 7 is my way I'm changing, or my common ratio that I'm changing with. So what would we say this one is? It's exponential. So we want to make sure that we are seeing all these different ways that we can go about changing in linear, or how we're changing when we've got quadratic, or how we're changing when we have exponential. We've got to look to see how we're changing, and do we change constantly? Are we constantly changing? Or is there a specific way I'm going from this point to this point to this point? Good job. All right, let's create equations from all three of these tables. So these are the exact same tables that we just worked with. So let's see if we can come up with some equation for these tables. So let's look. So I know that this was linear. I know that this was quadratic. And I know that this is exponential. So with me knowing those, I've got some balance of y equals mx plus b, or ax squared plus bx plus c, or y equals ab to the x. So what I'm wanting to do is I need to be able to go from these tables to these equations. So how could I possibly do that? Could I possibly use my tools to do this? Absolutely. Everybody grab your calculator. We're going to put these tables in our calculators and let our calculator come up with our equation. Ms. Killen, no way, absolutely. So no longer am I having to struggle to find that common ratio, or find that slope, or see what my y-intercept is. Now, since I've learned all that information, now I can allow my calculator to do that for me. So let's see. So what I'm going to do is I'm going to use my first table, and I'm going to put that first table in my calculator. So let's see. Whoops, wrong calculator. I need this calculator. All right, so everybody pull up your TI-84 calculator. I'm going to make it so everybody can see it. So what I'm going to do is pull this up, and hopefully it'll work. There we go. All right. So the first thing that we're going to do to plug these into our calculators is we're going to put them in the tables. So for us to put a table in, we're going to go to Stat. We are going to go to number 1, which is Edit. So I'm going to go to number 1, Edit. Now remember, my L1 is my X values, my L2 is my Y values. So let's go ahead and put that first table in. So I have 0. And I have 1, 2, 3, and 4. Now I'm going to scroll right and put my y values in. 7, 13, 19, 25, and 31. So I've got both my x and y values in. So the next thing I'm going to do is I'm going to go and do second quit. And I'm going to go back to Stat. Now I'm going to scroll to the right and go to Calculate. Now, these are the different types of regressions and variations that we can find in this calculator. We've already found out that this is a linear equation, so I'm going to go down to my linear regression, which is number 8, and I'm going to press Enter. My x values are L1, my y values are L2, so I'm going to go Enter, 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 down until I have Calculate, and I'm going to press Enter. And it tells me here that my A is 7 and my B is 6. So when I go back and I write this, I am writing y equals 6x plus 7. So I'm wanting to keeping in that y equals mx plus b form. Now, my calculator is not going to say m or x or b, it's going to give you your a and b and show you where that is in that equation. So that's how we've got to make sure that we're looking at this. All right, so let's do our next one. All right, so I'm going to pull this back up, make this smaller, or let me go back to here. All right, so I'm going to do second quit. I am going to go back to my Stat button, and I'm going to put another table in. So I'm going to go to number 1. Now, Ms. Killen, I have something in my columns. I need them to go away. So you're going to scroll up to where you have L1 and L2 highlighted. You're going to press Clear and Enter. We're going to do that for both my list. Clear, Enter. So now let's put our new list in. Let's put our new table in. So I have 0, 1, 2, 3, and 4. And then I'm going to put my y values in, 7, 13, 31, 61, and 103. All right, so now that I've got my table in, I need to pull up that regression. So I'm going to go back to my stat, going to go to the right to calculate. Now we said this was quadratic. So I'm going to go down to number 5, which is my quadratic regression, and press enter. My x values are list 1, y values are list 2, so I'm going to keep pressing enter till calculate. And then it tells you where a, b, and c is in your equation. Then it tells you what a, b, and c is. So let's go back and write that. So I'm going to have y equals 6x squared. We did not have a b, but we do have a c. So let's put our last one into our calculator. And let's go back and do second quit. We're going to go back to our stat list and go to 1 because we need to edit. We need to clear out these lists, so I'm going to highlight L1 and press clear enter. I'm going to highlight L2, clear enter. Now let's put our new table in. 0, 1, 2, 3, whoops, 3 and 4. Then I'm going to put my y's in, which were 6, 42, 294, 2,058, and 14,406. Whew, those are some big numbers. So I'm going to go back to stat, go to the right to calculate, and this is my exponential regression. So I'm going to go all the way down to 0, exponential regression. Press enter. L1 and L2 are in the proper places. And I'm going to do calculate. And it tells me what is A and B. So let's go back and write that. So I have y equals. Now, what did it say? Let's make sure that we write down exactly what it says. 6 is my A, 7 is my B. So I want to make sure 6 is my A, 7 is my B. So I have taken my tables, plug them into my calculator, and now my calculator is writing my equations for me. No longer do I have to guess. All right, so let's look and see what else we got. It says, consider the questions about each function, indicate which function is it referring to. Now, I'm going to give you about 5-10 seconds. I want you to just run through this and see if you can answer it real fast, and then I'm going to answer it for you. So everybody look, about 5 or 10 seconds, and then we'll do it together. All right, the characteristic is a constant rate of change. Which one did we say has a constant rate of change? It is linear. All right, so my next one says a graph has a vertex. Which one did we say had the vertex? Quadratic. The range is all real numbers. We said that it is our linear. We also said that it was our quadratic. And we can also say that it is our exponential. The range can be y such that y is less than 0. Which one did we say that? Yes. Domain can be from negative infinity to positive infinity. We are saying that can be all of them. Can have one y-intercept, and that is, again, all of them. All right, the second difference is a constant change. Which did we have to find that second difference? Quadratic. Range is y such that y is greater than 0. And we said that can be the quadratic and the exponential. Graph has no x-intercept. So for it to not have an x-intercept, that could be linear, quadratic, and exponential, depending on what it touches. Can have 2 roots. Obviously, that's going to be our quadratic. And our range cannot be y is greater, or y cannot greater than or equal to 0, and that is my exponential. So we want to make sure that we've got all of these different characteristics and indicate which function those characteristics go with. Good job. So now let's do some practice. We have 3 different tables. Which table represents a linear function? Which table is the constant difference for a quadratic function? Excuse me, what is the constant difference for the quadratic function? And by what are we changing in the exponential graph? So let's go ahead and start. When I look at this green table, I go from 10 to 2, from 2 to negative 22, from negative 22 to negative 62, and to negative 118. Obviously, I'm not adding a number because I would not be adding the same amount. So what am I doing? Well, to go from 10 to 8, I know I subtract 8. To go from 2 to negative 22, I am subtracting what? Well, Ms. Killen, I'm not quite sure. Well, let's grab our calculator. If I go from 2 to, I go to negative 22, I am what? Subtracting 24? Let's see. 2 minus 24, I get negative 22. So what do I do to go from negative 22 to a negative 62? I am subtracting 40. And then to go from negative 62 to negative 118, I am subtracting 56. Now, obviously, the first change is not linear. But what am I doing each time I'm changing? I'm changing by 16 here. I'm changing by 16 here, and I'm changing by 16 here. So my change is constant in that I'm changing by 16 each time I change. So that means it's a what? It's a quadratic. Good job. Let's look at the purple one. The purple one, I'm going from 2 to negative 20 to positive 200 to negative 2,000 to a positive 20,000. Now, obviously, I'm not adding anything. So what could you say this is? How am I changing these? I'm changing them exponentially, yes. So let's see what we're doing. So to go from 2 to a negative 20, I am multiplying by negative 10. Well, let's see if that works again. If I take negative 20 and negative 10, I get a positive 200, so I'm multiplying by negative 10. If I take 200 and multiply it by negative 10, I do get a negative 2,000. And then if I take the negative and negative, 2010, and multiply, I do get a positive 20,000. So yes, this is an exponential equation. So obviously the last one's linear, Ms. Killen, but is it though? You always want to make sure that you do the math. No matter if you have, it has to be this, it has to be this, it has to be this. You always want to make sure that you do all of your options, because let's say that we made a mistake somewhere. And then we find this one is truly something, so then we have to go back. So you always want to make sure that you work all the problem to make sure that you've done the problem correctly. So let's do this last red one. All right, so I'm going from 10 to 18, I am what? I'm adding 8. When I go to 16 to, when I go from 18 to 26, I'm adding 8. When I go from 26 to 34, I am adding 8. And from 34 to 42, I am adding 8. So obviously we were correct in saying that is linear. So now that we figured out which one of these graphs is what, let's go ahead and answer the questions. It says, which table represents a linear graph or a linear function? So we're going to put red. What is the constant difference in or for the quadratic function? It's going to be 16. That's how much we said the constant change of the changes were. And by what are you changing in the exponential? We are changing by a negative 10. So once we figured out which one was what and how we changed and what we did to change, the questions were simple, simple, simple. All right? Time for you to practice. Make sure that you look back at your notes for the help. Make sure that you are looking and comparing what you've got. So here we go. It says determine whether the following real-world scenarios are linear, quadratic, exponential. You've got driving at 35 miles an hour, jumping off the diving board, your jack-o'-lantern dying on the porch, hitting a golf ball 200 meters, cheese left on the counter turning green, and driving from Tupelo to Gulfport in 4 hours. You and your table partner, go ahead and look at these, pick which one you think is what, then come back to me and we see what we got. Okay, so I'm going to go through these. I'm going to read them. I'm going to see what we've got and see if my work is what you got. So here we go. I am driving at 35 miles per hour. So every mile I am driving 35 no matter what. I'm going to say that that is linear. Jumping off the diving board. Now, remember, here's your diving board. Here's the water below. I'm going to jump off the diving board. Well, that to me looks like a parabola. So that is obviously a quadratic. Okay, your jack-o'-lantern dying on the front porch. Now, the first couple of days in October, your jack-o'-lanterns look really, really pretty. They're really, really scary. And about day 20 to 25, it starts looking really, really bad. So it looks fine, and then it really starts to look really bad. So that's going to be a what? Exponential. Good job. All right, hitting a golf ball 200 meters. So here's my tee with my golf ball, and I hit my golf ball, and then it comes back down. So what could I say that would be? Exactly right. This one is also going to be quadratic. All right, cheese left on the counter turning green. Turning green. Okay, I hope you're not eating the cheese. But obviously, the first couple of days, it's just getting a little soft, and it still looks like cheese. But then you come day 7, day 12, day 14, and the smell is getting bad, and it's starting to smush down and it's starting to turn green. So that's going to be exponential, yes. All right, driving from Tupelo to Gulfport in 4 hours. 4 hours. What are we doing? Exactly right. That is going to be linear. Good job, guys. We don't want to forget, each function has its own equation. Depending on the function depends on the change from one point to the next. Some functions has limits on their ranges. We want to remember that our linear, our quadratic, and our exponential functions, they all have their own individual personalities with their own individual key features of these functions. I am so glad that you came to learn here with me at MPB. We are going through this Unit 9. We are learning and reviewing, so you want to make sure that you're reviewing with us. I want you to have a great day.